Before you, before me, before anything at all, there was nothing. No space, no time, not even darkness, because even darkness needs a place to exist. And yet, in that no place, a possibility pulsed silently. The beginning. The ideas, the breakthroughs, the choices that shaped our world reveal how great minds thought, struggled, and built the future. Every lesson, every spark of brilliance is a minting of thought, and every invention, every battle, every vision leaves a trace. I'm Atlas, and I welcome you to a journey where history fuels your growth. This is Mind Mint. Before we begin, subscribe and hit the bell so you never miss a story. And when we're done, leave a like if this chapter sparked your curiosity. Now, let's uncover the details behind today's story. We call it time equals zero. From nothing, a singularity emerges. It doesn't explode inside space. It creates space. In an unimaginable blink, our universe begins to grow. Birth wasn't filling an emptiness. It was inventing one. In a fraction of a second, inflation. Every 10 to the minus 34 seconds, the universe doubles in size. Tiny irregularities become tomorrow's galaxies, tomorrow's stars, and eventually, you. Without that dizzy rush, nothing we know could exist. When the cosmos was smaller than an atom, all forces were one. As it cooled, they split. Gravity took its silent road. Nuclear forces built the workshop of the tiny. The rules of everything to come were being written, without ink. Quarks restless, gluons binding them, photons colliding endlessly. Matter and energy danced without names. From this chaos, protons and neutrons were born, the bricks that would one day hold up worlds. In the first 3 minutes, the universe forged hydrogen, helium, and a breath of lithium. 98% of all matter was decided in this dawn. Yet the essential ingredients for life, carbon, oxygen, iron, were still missing. Hundreds of thousands of years later, the universe stopped being opaque. Electrons and nuclei paired up, and light was released for the first time. That ancient glow we now call the cosmic microwave background, the baby picture of the universe. The dark ages followed. No stars yet, only gravity and patience. Small ripples, planted by inflation, gathered gas. In the quiet night, the first spark was preparing. Decades ago, Arno Penzias and Robert Wilson tried to clean a stubborn noise from their antenna. They checked wires, sealed joints, even cleaned pigeon droppings. The noise remained. It wasn't noise at all. It was the oldest whisper of the universe, the echo of the Big Bang. But there's still a hole in our table. The beginning forged only light elements. Where is the carbon that writes your story? The oxygen you breathe? The iron in your blood? The young universe did not create them. So, who did? To answer, we must ignite the first stars. The young universe is a quiet child. Nothing shines, nothing breaks the night, only oceans of hydrogen and helium waiting. But in those silent shadows, gravity begins to weave a secret. Tiny ripples, seeded since inflation, now become centers of attraction. Gravity calls, and atoms obey. Whole clouds collapse, swirl, and heat. The night is preparing its first fire. In a sacred instant, heat and pressure cross the impossible threshold. Hydrogen nuclei fuse into helium. The very first star is born, and the silence of the cosmos breaks with light. They were cosmic giants. The so-called population 3 stars. Enormous, brilliant, short-lived. They left no fossils, no direct traces. Their legacy is written only in the elements they forged inside. From their fury, the future would be born. Every star is an alchemist's furnace. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen. Layer by layer, the periodic table takes shape. But when iron appears, the fire can no longer feed itself. The star is doomed to die. Gravity wins. The star collapses and then explodes. A supernova, more violent than imagination allows. Iron, carbon, oxygen, calcium. Everything your body needs is hurled into the void. Your future scattered as shining dust. Each stellar death painted space with new elements. The universe was no longer only hydrogen and helium. Now there was carbon for life, oxygen to breathe, iron for blood. Stars were writing your destiny long before you existed. Stars are not born alone. They gather, they spiral, they collide, forming galaxies. Some majestic spirals, some massive ellipses, others wild clusters. These cosmic cities would cradle future planets, and perhaps life. But there's a riddle hidden in this early universe. Why is there more matter than antimatter? At the beginning, they should have annihilated each other completely. Yet a small excess of matter survived. That tiny imbalance is the reason we are here. The universe kept its trick well hidden. When we look with telescopes, we don't see the present, we see the past. The light of those first galaxies took billions of years to reach us. In their faded colors, we read the story of a universe just awakening. But soon, those stars and galaxies will reshape the very fabric of the cosmos and open the path for worlds to appear. Around every newborn star remains a swirling disk of dust and gas. At first, they look like leftovers of creation, but hidden in that chaos are seeds. Here, in these protoplanetary disks, entire worlds begin to take shape. Dust collides into dust. Pebbles become rocks. Rocks grow into mountains. Mountains into protoplanets. It's a violent ballet. Crashes, fusions, catastrophes. And yet, out of destruction, stable spheres emerge. The first worlds. About 4.6 billion years ago, our own solar system was born. 8 planets, dozens of moons, millions of asteroids and comets, all siblings from the same cloud that gave birth to the sun. The newborn system was a battlefield. Protoplanets smashed into each other. One of them, the size of Mars, struck Earth. From that chaos, fragments gathered, and in time, became our moon. The water we drink did not start here. It came from afar, carried by comets and asteroids. Each drop in your body may have once traveled the frozen edges of the solar system. Jupiter, the giant, played a decisive role. With its gravity, it swept thousands of wandering rocks. Some were expelled into deep space, others slammed into young planets. Without Jupiter, Earth might never have been stable enough for life. Close to the Sun, rocky planets took shape. Mercury, scorched. Venus, destined for a hellish sky. Mars, a red desert. And Earth, still molten, still chaotic, but preparing for a different fate. Farther out, the giants, Saturn, adorned with rings. Uranus and Neptune, frozen and majestic. Each of them shaped the balance of the system. Without their gravity, the solar stage would look very different. Not all matter became planets. Between Mars and Jupiter, a graveyard remains, the asteroid belt. Millions of fragments, worlds that never were. For hundreds of millions of years, Earth endured a brutal bombardment. Impacts sterilized and enriched it at once. They delivered water, molecules, maybe the very ingredients of life. Once again, chaos was the creator. Early Earth had no air to breathe. Slowly, gases from volcanoes and comets built an atmosphere, at first toxic and heavy. But with oceans, balance began to take shape, an atmosphere preparing for life. The crust hardened. Continents appeared like timid islands. The Earth was still hostile, but now dressed as a world. The stage was set for the next revolution, the arrival of life. Every planet, every moon, every rock in the solar system is a witness to those chaotic days. But Earth kept a secret. Here, among stone and water, something extraordinary was about to begin. Is Earth unique? Or out there, among countless other worlds, did life also begin? We don't know. What we do know is that here, the universe's dust was about to awaken, from rock and fire to the first spark of life. 3.9 billion years ago, Earth was not the blue world we know. Its oceans were cauldrons of chemicals, its sky toxic, its surface violent. And yet, inside this chaos, something unimaginable was preparing. The spark of life. Oceans became laboratories. Water mixed with minerals, gases, and energy. For millions of years, molecules collided endlessly. Every drop was an experiment written by the planet itself. From this restless soup, complexity emerged. Amino acids, sugars, lipids, the bricks of biology. Not alive yet, but already capable of becoming more. Billions of years later, humans would reenact this ancient chemistry. In 1953, Stanley Miller and Harold Urey sparked gases inside a flask. After a week, amino acids appeared, a modern echo of Earth's original experiment. But bricks are not a house. The greatest mystery remains. How did molecules learn to copy themselves? When did chemistry take the leap into biology? Scientists believe RNA, a cousin of DNA, may have been the first replicator. Simple, versatile, able to store information and make copies of itself. With RNA, life gained its first true voice. Some molecules found refuge in tiny bubbles made of fat. Protected from the outside, they had a safe space to multiply. Without knowing it, the first prototypes of cells had been born. Others suggest life began in the deep sea, near hydrothermal vents. There, Earth's own energy fueled endless reactions until one molecule learned to harness it for replication. We don't know the exact moment, but more than 3.5 billion years ago, the first organism appeared, capable of reproducing and evolving, the very first inhabitant of Earth. For billions of years, life was invisible. Microbes ruled in silence, unseen but powerful. From a fragile spark, they became an unstoppable tide. Today, the oldest fossils date back 3.8 billion years. Tiny microbial signatures carved in stone, ancestral handwriting of our beginnings. But another question lingers. Did life truly begin here, or did it arrive from space, carried by comets and meteorites? The answer remains a mystery. Once life took hold, Earth itself began to change. Tiny microbes were preparing to transform oceans, skies, and the destiny of the entire planet. A hostile planet became a cradle. The first living beings began a race that would last billions of years, a race toward complexity and toward you. But before reaching us, life had to learn how to breathe. For billions of years, life remained microscopic, tiny, simple, silent. The planet was alive, but not yet breathing. Then came cyanobacteria. Small, fragile, but revolutionary. They captured sunlight, split water, and released a byproduct no one had asked for: oxygen. At first, oxygen was poison. It rusted the oceans, turned them red, and threatened the life that had thrived without it. Entire species vanished. But what seemed like death was the beginning of something greater. Slowly, oxygen accumulated in the atmosphere. The sky changed. A fragile shield of ozone formed, protecting Earth from deadly radiation. For the first time, life had room to grow beyond the oceans. Oxygen was dangerous, but also powerful. It allowed cells to generate far more energy than ever before. With that energy came possibilities. Bigger, more complex, more ambitious forms of life. Around 2 billion years ago, one cell swallowed another. Instead of digesting it, they became partners. Inside its host, the smaller cell became a mitochondrion, an energy factory. This was the birth of complex cells, the ancestors of plants, fungi, and animals. Oceans cleared, skies turned blue, continents grew under a protective shield. The planet transformed into a stage ready for new actors. Earth was no longer hostile. It was a cradle prepared for complexity. Even today, stromatolites, layered rocks built by microbes, stand as monuments to that revolution. They are living fossils of the first architects who taught Earth how to breathe. For almost 2 billion years, microbes dominated, but the oxygen they produced was setting the stage. Pressure was building, silently, patiently, for an explosion of life unlike anything before. Why here? Why did Earth succeed where so many other worlds remained barren? Perhaps it was chance, perhaps design. But what is certain is that oxygen changed everything. And with oxygen came the first great explosion of life. For most of Earth's history, life was simple. Invisible microbes ruled. The oceans were alive, but silent. No eyes, no teeth, no movement beyond drifting. But oxygen had transformed the planet. The seas were clearer, richer, and filled with possibilities. Energy was no longer scarce. The stage was prepared for something extraordinary. About 540 million years ago, life crossed an invisible line. Suddenly, in a geological blink, organisms became larger, stronger, more diverse. The Cambrian explosion had begun. Eyes appeared, an evolutionary revolution. For the first time, creatures could see and be seen. A new game began: predator and prey. Predators invented teeth, claws, speed. Prey responded with shells, armor, and tricks of survival. Evolution became an arms race, and life, a battlefield of innovation. In the Cambrian seas, bizarre creatures flourished, some familiar, others alien. trilobites with armored bodies, hallucigenia walking upside down on spines, Anomalocaris, a predator with grasping claws. Nature was experimenting wildly. For the first time, complex ecosystems appeared. Hunters, grazers, scavengers, each had a role. Life was no longer just survival. It was interaction, competition, balance. In just a few million years, almost every major animal group appeared. Ancestors of insects, fish, even us. The Cambrian explosion wrote the blueprint for nearly all complex life on Earth. Today, we can still see them. In fossil beds like the Burgess Shale, these creatures remain frozen in stone, time capsules from a world that invented eyes, predators, and the first great web of life. Why here? Why did Earth ignite with complexity while other worlds stayed silent? Was the Cambrian explosion inevitable, or a rare miracle? From nothing, to light, to stars, to worlds, to life, to us. The story continues, because we are the universe, telling itself. For millions of years, the oceans were the only stage for life. But then, 400 million years ago, some creatures dared to leap. For the first time, land became a frontier. The conquest had begun. The first to venture were plants. Mosses and early vascular plants colonized bare rock, creating soil and shade. They prepared the ground for all who would follow. Arthropods were the first animals to conquer solid ground. Scorpions, as long as a human arm, giant millipedes, and strange early hunters filled these landscapes. For the first time, land pulsed with movement. Leaving water was a titanic challenge. Breathing air, resisting gravity, avoiding dehydration. Most failed, but some fish evolved primitive lungs and stronger fins. They were the first steps toward a new way of life. Among them was Tiktaalik, discovered in the Canadian Arctic in 1996. Not quite fish, not yet reptile, a true living bridge. Its fins could support its weight, allowing it to drag itself onto land. A link between two worlds. From these pioneers came the first amphibians, creatures living in two realms, still dependent on water, but they had opened the door for generations of explorers to come. Plants transformed the atmosphere, releasing oxygen in unprecedented amounts. Air grew rich, dense, and giant insects thrived. Dragonflies the size of crows soared over endless forests. Earth became lush and strange. About 370 million years ago, the first forests appeared. The planet dressed in green, reshaping both climate and atmosphere. Land was no longer barren, it was alive. True independence from water came with a silent invention, the amniotic egg, a private ocean inside a shell. Now, life no longer needed to return to water to reproduce. Land became a permanent home. The first reptiles with tough skin and protected eggs spread across continents. Small, agile, relentless, Earth's new rulers. The arrival of animals on land triggered a domino effect. Plants grew taller, insects multiplied, and the food chain grew more complex. The planet would never be the same again. In just a few million years, land turned from barren rock into a stage overflowing with life. The face of Earth had changed. What began with moss and small insects soon gave rise to something much greater. Colossal creatures, absolute rulers of the Earth, were about to appear. The kings of the world were preparing for their reign, the dinosaurs. Just 2 million years ago, an eye blink in cosmic history, something extraordinary happened. Among Earth's creatures, one species learned to walk upright, to shape tools, to command fire, and to wonder where it all began. The iron in your blood, the calcium in your bones, the oxygen in your breath, all were forged in the hearts of ancient stars. Every atom in your body carries a cosmic lineage. Centuries later, some of us looked up and began to decode the universe. Galileo, Newton, Curie, Einstein, each added a piece to the puzzle, revealing the dance of atoms and stars. In the vast emptiness of space, life on Earth is a fragile miracle. A delicate balance of atoms, energy, and chance allowed you to exist. You are, quite literally, stardust looking back at itself. But the same atoms that gave us life were turned into weapons. From stone spears to atomic bombs, we learned that our power could create or destroy. Yet across every age, one feeling remains, a deep connection to the universe. When we look at the night sky, we remember, we are children of the stars. And here you are, listening to this story. Every breath you take, every thought in your mind, is the outcome of a journey that began 13.8 billion years ago, the journey of your atoms. Today, those atoms give you the power to shape the world. With knowledge, you can protect this planet, explore others, and perhaps uncover the mysteries that still lie hidden. Think about it. The atoms that once formed mountains, oceans, and suns now form you. You are the continuation of that story. You are the universe made conscious, from the Big Bang to you. That is the journey of your atoms, and the story has only just begun. And so, dear listener, that's where today's story ends. Let's continue walking the path of great minds and moments together. Remember, every great mind was once just curious. Stay curious, and I'll see you in the next chapter of Mind Mint. Goodbye.